All right, welcome to part two of our lecture. Excuse me, this is the first part of our lecture series from Wednesday, April 12th, where we warm up trying to put together all of what we know so far about doing stoichiometric calculations, as well as identifying and utilizing information about limiting reactants in those calculations. This problem is one that, like I mentioned earlier, is a little bit challenging because I have thrown in a lot of embedded review about things like calculating mole quantities from molarity. And we're also going to explore in this warm up the idea of not only a limiting reactant, but also a reactant that's left over in excess. So here's the problem. We are told that 0.872 grams of metal zinc solid is reacted with 15 milliliters of 3 molar hydrochloric acid to form zinc chloride and hydrogen gas. So we're given information about our recipe as well as our pantry, meaning we can ultimately get our balanced chemical reaction and then our mole quantities from the lab amounts of each substance used. And then the problem asks us, what is the concentration of the resulting chloride ion in solution once the reaction is completed? So we really want to know the concentration of chloride ion. That's the goal here. So let's go ahead and start with what we know about our reaction, meaning let's get our recipe, the balanced chemical equation, figured out so that we know in what proportion our zinc and our HCl need to react in order to form zinc chloride and hydrogen gas. So let's start by getting our balanced chemical equation. Again, I've been referring to this as our recipe. So let's see here, we have solid zinc that is reacting with hydrochloric acid to form zinc chloride and hydrogen gas. Hydrogen gas, that is one of our homonuclear diatomic elements, so H2. And then zinc is one of our transition metals that has a fixed charge state. Zinc is always the +2 cation. Chloride is the -1 anion. So if I am going to make zinc chloride, I need 1 zinc and 2 chlorines. And this is an aqueous solution. And if I'm going to balance this, then I need to double my hydrogen on my reactant side by doubling my hydrochloric acid. In doing so, that will double my chlorine, which works out because I needed those 2 chlorines to form my zinc chloride on my product side. And then we are 1-to-1 with respect to zinc. So this is our balanced chemical equation. This is our pantry. No, excuse me, this is our recipe. So again, this reads that we have 1 mole of zinc reacting for every 2 moles of HCl in order to create 1 mole of hydrogen gas and 1 mole of zinc chloride. Okay, now let's look in our pantry. Let's see what actual mole quantities we have available to react. So we know a mass of zinc, 0.872 grams, and we know a volume and a concentration of HCl. So let's try to at least get our initial mole quantities. So these are our initial or pre-reaction mole amounts. All right, how about we start with our zinc? So I am given a quantity of zinc that is in grams. And remember, when I am given a balanced chemical equation, I'm given a ratio of moles that are reacting in some proportion in order for the reaction to proceed. So since I need to use my mole ratio as my conversion factor to relate quantities of things that are reacting in some kind of chemical reaction, then I cannot simply leave my quantity of zinc in a mass unit. Rather, I need it in a mole unit. So I need to get a mole quantity. So thinking about what relates moles and mass, that is molar mass. So I want to cancel out grams of zinc and be left with moles. And remember, molar mass tells us how much 1 mole of any substance weighs. So from the periodic table, 1 mole of zinc weighs 65.38 grams per mole. So if I were to take my 0.872 grams and divide by my molar mass of 65.38 grams per mole, I get 0.0133, and then that is my 3 sig figs required, but I'm going to carry my 374 for my calculations in the future. Units cancel, and this gives me moles, and I'm going to label moles of what, because now in chemical reactions we got a bunch of different things happening. So this is moles of zinc. All right, so this is our initial moles of zinc that we have available to react. Let's do our hydrochloric acid. Okay. So anytime we are looking at an aqueous substance where we have a concentration, like a molarity, remember molarity, capital M, is a proportion of moles per liter. So just like molar mass relates moles and mass, molarity relates moles and liters. Larity, liters, L. So volume. Which means I've got to take my volume of HCl, which was my 15 milliliters, and first convert that into liters, because my proportion that relates moles and volume is in moles per liter, right? That is what molarity is by definition. So there are 1,000 milliliters for every 1 liter. And then continuing this calculation so I can knock out both conversions at once. Using my molarity, I know that per 1 liter of HCl solution that's given in this problem, there are 3.00 moles. In other words, the molarity is 3.00 moles per liter. All right, so that is going to be 0.15 times 3, 0.015, which is 0.045. And then the 3 sig figs, 0.450. This is a whole even number. I don't have any kind of trailing digits, so here I am, 0.0450 moles HCl. All right. We are almost done getting things ready to do our actual stoichiometry or our mole conversions, which is going to include our limiting reactant analysis. However, if you remember from our last lecture, I said that anytime you perform stoichiometry or do stoichiometry based on some balanced chemical equation, the recipe that you really want to follow is the net ionic equation. So let's try to get these mole ratios that deal with the things that are like actually interesting in solution. All right, so if I were to start with my reaction just as is, I would have solid zinc reacting with 2HCl to form hydrogen gas and zinc chloride. Actually, you know what? That's not going to be helpful in this particular example. Ignore what I said. Because then the chloride, no, I think we'll be okay. H2 gas plus ZnCl2 aqueous. So the net ionic equation then, you'll notice we'll have two chlorines that cancel, so this will be solid zinc. This is not zinc ion, so it will not cancel with the zinc that's over here. Coming together with two H pluses to yield H2 gas and zinc 2 plus ion. So this is the net ionic equation that we're going to use to do our stoichiometry. Okay. So all of this work was just setting up kind of our pre-reaction initial conditions, right? We know the mole ratio or our recipe that tells us in what proportion our things need to react together in order for this reaction to happen in the first place. And then we also know what's in our pantry. We know what our mole quantities that we have available to us are in order to react. Like we know how much of these things we're mixing together expressed in mole quantities. So in the second half of this video, because I don't want this to be like, a massive 20-minute long problem video, we are going to look at the actual stoichiometry, where we're asked some kind of question about what happens post-reaction. So since we want to know something about the chloride ion in solution, then we are going to need to perform our stoichiometry and check for any kind of limiting reactant, because remember, a limiting reactant is going to dictate how much product is formed. All right, here's what I'm going to do. I'm going to change this real quick to not chloride ion, let's do zinc ion. You will see why in a moment. All right, so we will continue this problem in the next video coming up.